Hi everyone! Do you guys know about the three types of radiations? First type is alpha particle, second type is beta particle, and the third type is gamma ray. So, alpha particle is a positively charged of helium nuclei. Beta particle is a negatively charged of electron, and gamma rays is a very high energy of photon. So, next is about half-life. Do you know about half-life? So, let's check it out. So, basically, half-life is time required for half of a sample to decay. So, the half-life is actually depends on the sample we use. So, this is the one of the example when the thorium is turning into protactinium by beta decay. So this is, let's say we start with 80 gram of thorium. So after 24 days, it's gonna left by half into 40 gram of thorium. So another 24 days, it's left 20 gram of thorium. So another 24 days, it's left by 10 gram of thorium. So we can say that the half-life of this decay is 24 days. So for someone that have visual type of person, so we can see this is the graph of half-life for thorium turning into protactinium. So we can say this is the amount of the thorium at we start. So by one half-life, so decreased by half. So another half-life is decreased by half, and another half-life is decreased by half. Okay, we're gonna look at the formula of the half-life. So A is determine activity of half-life, or we can say this is the rate of the decrease in the number of nuclei is proportional to the number of nuclei present. So the N is the number of nuclei, and it is the time change. Or we can conclude that this is negative lambda n, because n is the number of nuclei, and the lambda is a decay constant. So A is refer to the activity, and n is refer to the number. So A is expressed of its activity. N0 is the initial activity of the nuclei. So this is the exponential and to the power of negative lambda t. Or we also can express this by number of nuclei. This n is the number of nuclei, N0 is the initial number of nuclei, exponential to the power of negative decay constant times of t. So another equation is equation of half-life itself. So after derivations, we can get the half-life is equal to ln 2 over decay constant, or we can simplify as ln 2 is equal to 0.693 divided by lambda. So next, we're gonna look at the uses of the radioactive decay. First uses is carbon dating. We use carbon dating to determine the actual or absolute age of the object. Or maybe you can say that if you found a fossil, then we want to know the actual age of the fossil, so we can use carbon dating. So the second one is radioactive tracer. We use beta particle and gamma ray to trace the chemical reaction in our body. So maybe in medication, we put radioactive tracer in our body so it can trace whether it has a chemical or not. So the last one is smoke detector. So when the smoke enters the chamber, which is content of alpha particles, so the current will decrease, then the alarm will sound. So we know that there is a smoke.